If you're like me, you really like some of those patterns in the cellular automata simulation that we did together, and you'd like to save them. In this episode, we'll do just that. Let me show you. I'll run example 4C on a 57 by 57 grid. You can see I've changed at least two things about this program. One is how the pixel color is determined from step to step, and the other is these new functions with the keyboard. I can use the spacebar to pause the simulation. I can press the S key to save a file, and after resuming the simulation for a little bit just to get it to change, and then pausing, I can press the L key to reload that original configuration. How is that done? It's done using the file system, and we can see it in the Phoenix Max directory. If you select map.txt, you can see that the date modified is 1:53 p.m. today, which is just now. And so you can see I just wrote that file by pressing the S key, and the size of the file is about 9 kilobytes. Opening it up with a text editor, you can see that it contains what looks like a 2D array in Python. Very simple. It's got zeros, ones, and twos in it. How did I do that? Let's take a look. And meanwhile, I'll let this run just to give us a distraction. Okay, so here's the file on the right, example4c.py. The beginning is pretty much the same. Let's look at where we save and load the map. I set the file name to map.txt. Then I check if the os.path.isFile file name. That checks to see if the file already exists. If it does, I explicitly remove it. This is to prevent the case where you try to write an array that's small to a file that already contains a large array in it, and then it causes those two arrays to be present, one partly overwriting the other, and that might be a file that can't be loaded. So I just explicitly remove the file ahead of time. That way, I can open a new file and write to it, and then close it without worrying about what was there beforehand. Files need strings to write to them, so I need to turn this 2D array into a string. To do that, I use the package Json. Json.dumps will dump this object into a string. It doesn't have to be a 2D array. You can supply this function with any object or list of objects that you want. That makes it very convenient for all kinds of applications, including network communications. Okay, now that you've saved the file, suppose you want to load it. It's so easy. First, I check if it exists. If so, I open the file name here with read permission instead of with write permission. And then I read all the string data from it with sf.read. And then I simply call json.loads, and that loads the string back into an object in Python. I do that separately for map and map2 because, as I referred to earlier, I don't want those two arrays pointing to the same location in memory. Whoa, would you have a look at that? The simulation ended. Isn't it interesting? In this case, the simulation starts with a single perturbation. I set the middle of the map equal to 1 only once at the very beginning, and everything that we see after that is an echo or a ripple of that one impulse that we see at the beginning. To me, this has a certain poetic feeling to it, like ripples expanding outward. To see that they actually end after a certain time also has a feeling of poetic justice, or something like that. Let's talk a little bit about the new rules that produce these patterns. Instead of checking to see if a pixel has an odd number of neighbors, this time we use a different rule. There's a different case for each number of neighbors. If there are 0 neighbors, then in the next frame the pixel will be blue. Same thing if there are 6 or more neighbors. But if there are 1, 3, 4, or 5 neighbors, then a pixel will be gray. And if there are exactly 2 neighbors, then a pixel will be white. And you have to keep in mind that we can access 8 neighbors by having 4 neighbors that are all of power 2. So it's really the sum of the numbers in the neighboring tiles. And this simple rule combined with a simple impulse at the very beginning gives us this dizzying complexity and an opportunity to save some interesting patterns. Why don't you try out changing these rules, or changing the game window size, and saving the patterns? Or you can change the map colors. You could even try more than just two or three numbers. You could have 4 or even 5 different colors. Try something out and see if you can find something that you like. Then you can save it and share it with us. All right, well, give it a go, and see you next time.